Hello everyone, welcome back to Cambridge Guru. We are doing the last chapter, which is complex number, and the previous video was about modulus argument form of a complex number, which is given in the form of a plus ib, right? And we did how to convert this a plus ib form into modulus. Means we first find out the magnitude of the complex number and then finding out the angle which it is making with the positive x-axis, or in the sense of complex number with the real axis. And I gave you the idea of how it is related to the vectors, right? In the vectors also we gave the magnitude form of a vector, but there is a slight difference between the representing a complex number in its modulus argument form, right? The process will remain same. It is just like the way of writing the complex number in modulus argument form is a little bit different, right, compared to the vector form. So we do not write modulus. For example, in the first part, if I say that the magnitude of this is 4 square plus 3 square root, which is 5, and argument of this will be tan inverse 3 by 4, right, whatever is the value. I think 36 point something, right? So this is the argument, this is the magnitude, and we do not write this in the form of 5 comma 36.9 degrees. Okay, we do not write in complex number like this. So how to represent this in modulus argument form, let us see. For example, this very first example I am taking. Let us plot this in an Argand diagram, right? How this vector will look like. So this is our real axis, this is our imaginary axis, right? And this is 4 units and this is 3 units. Okay, and let us say this is my complex number, right? And it is making an angle of theta with the imaginary, with the real axis, right? So if I join like this, this point in the Cartesian plane will be 4 comma 3, right? This is same as we did in vector form, right? But and since this is the modulus of z, so I will write this vector, or this red vector, this is the magnitude of this complex number. So in terms of this magnitude, how I can represent this 4 and this 3? So simply applying the trigonometric rules, I will write this, that this distance is mod z cos theta, and this vertical distance will be mod z sin theta. If you apply the trigonometric ratio sin theta and cos theta in this triangle, you will say that sin theta will be z by 3 and 3 by z, and cos theta will be 4 by z, right? So this 3 is basically mod of z sin theta, and this 4 is mod of z cos theta, right? And since the original complex number is 4 plus 3i, so if I write this z as 4 plus 3i, and now replacing this value of 4 and 3 by mod z sin theta and mod z cos theta, right? So basically writing this number 3 and 4 in terms of theta and the magnitude, which is 5, right? So since mod z here, I am representing this r with mod z, so mod z is 5, right? So writing this z is 4 as mod z cos theta plus I times 3 is modulus of z sin theta, right? And what is this mod z? It is 5. So this is 5 cos theta plus I times 5 sin theta. Taking out this 5 as a common factor, so complex number z now can be written as 5 in the bracket we have cos theta plus imaginary part of sin theta, right? So now this is the representation of any complex number in the form of magnitude or modulus argument form, where this theta you can write the value in terms of not in degrees, but this pi has to be, this theta has to be in radians. So converting this 3 by 4 in terms tan inverse 3 by 4 in its radial form, you can substitute the value of theta, right? So this is the proper representation in the form of modulus argument form. Okay. Now difference lies, as I have already said in the previous video, that since this theta was in the first quadrant, means it is acute because both x and y, both the real and imaginary portion are positive. In the second part, this tan inverse theta will be -1, all right, -45 basically, right? Since its real part is negative, its imaginary part is positive, so it is basically lying in the second quadrant, right? So let us do this second part also. Second is z as -1 plus I. Okay, so modulus of z will be √2, -1 square plus 1 square root. This is √2, and argument of z will be tan inverse 1 upon -1, right? Finding out the principal value. Principal value means avoiding this negative sign, so I get the basic value as the acute angle theta will be 45 degrees, or simply pi by 4, right? But since this x, let me plot this in an Argand diagram. This is -1, right, and this is plus I. Okay, so my z is like this. Okay, right. So now this is in the second quadrant, so this is your theta, which is basically, if I measure the theta in clockwise direction, so this is pi by 4, right? So basically, since this theta has to be clockwise, means it is -pi by 4, not -pi by 4. If I am measuring the angle from the negative side, right, then it is -pi by 4, but basically this theta is pi, this whole is pi, means moving the theta in anti-clockwise direction, so I will get pi, and then I'm moving in the reverse direction, so I will write -pi by 4, right? So this theta will be pi minus pi by 4, which is 3 pi by 4. Okay, so this is the argument, right? So writing this in modulus argument form will be that this z is √2 cos 3 pi by 4 plus I times sine 3 pi by 4, right? This is the answer. Okay, similarly we can do the third part. In this both the real and imaginary part are in the negative direction, so this point will be in the third quadrant. So theta, in this case we measure clockwise, right, whatever is the value. Okay, all right. Now let us take another topic, which is the set of points of a complex number in a complex plane, right? So it says that if I write mod z is equal to, let us say, 2. Okay, meaning of this is that if I measure, since modulus of any number, any complex number, is basically the distance, right? If I write this mod z, so meaning of this is that magnitude of a complex number is always equal to 2, right? And since we can represent any complex number in a Argand plane like this, right? So this z is moving in this complex plane, in this two-dimensional plane, in such a way that its magnitude is always 2, right? And if I'm talking about the magnitude, that means I have to take the initial and final point. If I'm talking about this, right, if I'm talking about this z, suppose this is my complex number, so I have this magnitude with reference to this initial point, right? I'm talking, let us say this point is a. Okay, so with respect to this initial point a, its magnitude is 2. So what is this point a? This we have to determine in this definition, right? So basically since it is, right, so it can move in this direction also, but condition is that its magnitude should be 2. It can move in this direction, it can move in this direction. Following this condition, it can move in any direction. Okay, it can move in any direction, but condition is that its magnitude should remain 2. So the magnitude of this arrow is always 2. So all the set of points, obviously we will get infinite set of points in this plane, right? You will get a circle. As you can see here, that as this will move like this, so this all these points will form a circle in such a way that its magnitude is always 2. And what is this magnitude? This is basically the radius. Okay, this is basically the radius, right? So basically mod z is equal to 2. It simply means that it represents a circle whose radius is 2. But what about the center? What about the center? So center is this point, right? But here this is not basically mod z equal to 2. I'm just showing you the meaning of what do you mean by equal to something, equal to constant, right? So this is not basically mod z equal to 2. It is something mod z minus a magnitude is equal to 2, where now this a is the center of this circle, right? So this point a has some coordinates, right? It has some real and imaginary portion, right? Such that the distance of all these points which are moving in this z plane following this condition that its distance from this fixed point a is always 2, right? So basically the basic function or the general form of general equation of a circle in complex plane is represented by mod of z minus a is equal to 2, where a is the point of center of that circle and equal to something that will be the radius. Okay, so and this a obviously will be, since this point we are talking in terms of complex plane, so this a will have a real part and imaginary part. It is not necessary that it always have both the parts real and imaginary. It could be only imaginary, it could be only real portion, right? And as you know that since complex number is the superset of all the real numbers, so it may include only the imaginary portion or only the you can say the real portion, right? So let us take a couple of questions on how to represent the complex number given in this form modulus of z minus something is equal to some constant. Okay. So set of points in an Argand plane. Example is that draw an Argand diagram showing the set of points z for which modulus of z minus 3 minus 4i is always equal to 5. Right. So as I told you in the discussion just we have done, that this can be written as z minus some point a, right? And this point inside the bracket I can put 3 plus 4i just to write in general form. And what is this general form? That z minus a mod is equal to some constant r, where r is the radius of that circle. So this basically represents a circle whose center is 3 plus 4i, or simply the point 3 comma 4, right? And its radius is 5, right? So now let us draw this circle in the Argand diagram. Let us take this as the imaginary, this is the real part, imaginary part of z, this is real part of z, and let us first locate this center which is 3 plus 4i. Now remember what you have to do is you have to take out this minus sign as a common factor, right? Because general form is z minus a, the distance between all the points which are moving in this two-dimensional plane, right? Between that means the distance of all the points moving in this two-dimensional plane with a fixed point a. So this will be represented by z minus a. So you have to take minus sign outside. So I get a point 3 comma 4. So 3 is the real part. Let us take this is 1, this is 2, this is 3, this is 4. Similarly on the y-axis 1, 2, 3, 4. So 3 comma 4 is this point. Okay, and the radius of this is 5, right? So you have to draw a big circle, because if you count the distance, this vertical distance is 3. Okay, this vertical distance is 3. right? So definitely if you have to draw a circle whose radius will be 5, it will be a big circle whose center will be 3, 4. Basically, no, this is 3, 4, this is basically 4, not 3. This distance is 4, right? So it will be a big circle, so it will cross this real portion and it will goes down to this horizontal axis, right? And this distance is 3, so it will go towards left also, right? So let me try to sketch this circle. This will be like this, okay? So my art is not that good, but just to give you an idea that how this will look like. And in order to find out this exact point where it will intersect the y-axis or x-axis, you can convert this into Cartesian form by writing any z as x plus iy, and opening up this bracket, you will find out the x and y coordinate also. Means the point of intersection with the x and y axis, not the x and y coordinates. Okay. If you find out the distance, since this is 5, so I can draw basically this. I can draw. Why I can draw? Because this is 3, this is 4. So I know that the distance of this center from the origin will be 5. Because in this triangle, this is 4, this is 3, this is 4. So this will be 5. And radius is also 5. So definitely it will pass through the origin, right? So now I have this 5, this has 5. Now I can draw better, because I know the point of intersection, which is that it will pass through the origin. Okay, so something like this it will look like. Fine. So that's all for today, right? And we will do a couple of more questions regarding the set of points in an Argand plane. Till then, bye bye, take care. I hope you have enjoyed this video. Please like, share and subscribe. See you soon.